All right, first of all, let's use solution. We use the rules backwards. Let's use the product rule 5. And we can actually group this portion. Well, no, before we use the product rule, we have to take care of those numbers in the front first. We can't use the product rule until we get rid of those factors, those numbers in the front. So this is rule 7. Rule 7 says this first guy, 5, 6 times log x, is the same as log base 2 of x raised to the 5, 6 power plus, and here's another application backwards of rule 7. It says that that's plus log base 2 of y raised to the 2/3 power. Let's do it again. Minus log base 2 of x raised to the 1/2 power, and then just bring down minus log base 2 of the number y. Okay, so all of that was done using rule number 7. I'll write it here. Rule 7 in reverse. All right, next we're going to use, let's see, let's just use the product rule backwards, rule number 5. In this line, we'll use rule number 5. This is equal to, putting these two together, a single log base 2 of a number, parenthesis, x to the 5, 6 times y to the 2/3. And then you got to be careful with this. Let's rewrite this as minus bracket log base 2 of the number x to the 1/2 plus log base 2 of y. And you might be saying, but why plus? Because I factored out a negative sign in the front of the brackets. That's why it changed signs. And now we can use the same rule backwards that we used before, and that's rule number 5. So bring down the equal sign, bring down log base 2 of the number x to the 5, 6 times y to the 2/3, and then subtract. Now in the bracket you're going to do log base 2 of x to the 1/2 times y. That's rule number 5 backwards. Now we're going to use rule number 6, the quotient rule backwards. So here we write rule number 6. You don't have to list all the rules, just use them. I'll know which rules you're using. So together we've got log a minus log b. That's log a over b. So this is equal to log, the common base 2, of the first, x to the 5, 6 times y to the 2/3 over x to the 1/2 times y. All right? So that was the log of the first number over the second number. Okay, now let's just do some algebra. This is log base 2. And inside of these parentheses we have x to the top exponent minus the bottom exponent times y to the top exponent minus the bottom exponent. That's 1, but we'll write it as a 3 over 3. It was y to the 1 on the bottom, but we wrote the 1 as 3 over 3 because we need a common denominator. We also need a common denominator for the x, so let's do something to that 1/2. We want it to have a bottom of 6, so we're going to multiply it by some funky form of 1, like 3 over 3. That's going to do it, because it's going to make a 6 on the bottom, 2 times 3, and whatever it makes on the top, it is what it is. So let's clean this up. Log base 2 of x raised to the 5, 6 minus 3, 6. That's what's happening there. Top times top over bottom times bottom. Times y to the negative 1/3, because 2/3 minus 3/3, you put the answer over the common denominator 3, but you do the operation across the top. 2 minus 3 is negative 1. So this is equal to log base 2 of the number x, 5 minus 3 is 2, 6, times y to the negative 1/3. But 2, 6 simplifies to the 1/3. 1, 3. So what we really have here is log base 2 of x to the 1/3 times, now let's make that a positive exponent. Write it as 1 over y to the positive 1/3. I'm using the rules of exponents there to write that, because y to a negative power is the same as 1 over y to the positive power. Now, you know that this is a whole number over 1 even if we don't write it, so we can multiply that together inside of the bracket. Log base 2 of top times tops, x to the 1/3, over bottom times bottom, y to the 1/3. Well, we can actually write this as log base 2 of x over y raised to the 1/3 power, or the cube root. I think I'll leave it as a fractional exponent. So that's our answer. It's log base 2 of x over y to the 1 power, or you may write that as log base 2 of the cube root of x over y. Same thing. All finished.